next I want to briefly talk about functions. So it's important to remember that a relation is any set of ordered pairs. And an ordered pair is any point on the xy coordinate plane. Like thinking back to college algebra, it's any point on the xy coordinate plane. A function is a relation where each distinct x value has exactly one y value. Let me repeat that. A function is a relation where each distinct x value has exactly one y value. How do I keep that straight? Well, what I like to think about is a vending machine, right? Each button you push, you get out a different snack, right? So let's talk about what it takes for something to be a function. So like I said, each x needs one distinct y value. So what does it take for a vending machine to function, right? I have my inputs, which are my buttons, and my outputs, which are food. So if I push C6, I get a Coke. If I put D7, I get Oreos. And if I push E8, I get chips. Okay? So when a vending machine runs, like I've got C6, it goes to Coke, D7 goes to Oreo, and E8 goes to chips. Each X has exactly one Y value. And this machine will function. Well, would my machine function if I had, for say, we'll try this again, C6 going to Coke, D7 going to Coke, nobody wants Oreos, and E8 goes to chips? Would this vending machine work? Yes, I push C6, I get a Coke. I push D7, I get a Coke. I push E8, I get chips. So I could have two X's going to the same Y. This is still a function. When this would not be a function is if, for instance, I had C6, that's supposed to be a C, C6 going to Coke and C6 going to Oreos. If I push C6, what do I get out? The vending machine's not going to give me both. That's not an option. This is not a function. This would cause my vending machine to not function. Function means something works. It would cause my vending machine to break. So let's state whether the following relations are a function. I like to do that by creating a handy dandy little XY table. So here's the XY table for problem A. My X values are 1, 2, 3. Very creative, I know. My Y values are 4, 5, 6. 1 goes to 4, 2 goes to 5, 3 goes to 6. Is this a function? Yes. Each X has exactly one Y. Each X has its own distinct Y value. Let's take a look at problem B. I have X and Y. My X values are 1, 2, 3. My Y values are 4 and 6. Just because there's two 4s, we don't count it twice, right? Remember, these are points on the coordinate plane. There's not two Y equals 4s. I have 1 go to 4, 2 go to 4, and 3 go to 6. Is this function? Yes. Each X has a distinct Y value. It doesn't matter if I push 1 and get a 4, I push 2 and get a 4. This is still a function. So I bet you've already guessed that C is not a function. You are so right. Let's go ahead and put our X values and our Y values, and I will show you why. 1 goes to 4, 1 goes to 5, 3 goes to 6. If I was to push 1 on a vending machine, what would I get out? This 1 doesn't have a distinct Y value. It has two Y values. So this is not a function. A function has some parts. So it consists of a set of inputs, a set of outputs, and a rule that assigns each input to an output. So a rule of a function is an equation. So if I have y equals 3x plus 2, this is a rule. I put in my x, I get out my y, right? The input is all possible x values, which is the domain. The domain of all linear equations is negative infinity to positive infinity, just as an example. The output is all possible y values. We call that the range. So from here I have from negative infinity to positive infinity for this example here where we have a line. Linear equations are functions. All polynomials are functions. We call x our independent variable, as it's the input, and we call y the dependent variable because it depends on what x is. When we say that y is a function of x, we can symbolically write it like that. So our example function would be f of x is 3x plus 1. And we read this, and I'll say it, f of x is how that would be read. When I'm given a graph of a function, or what I think might be a function, I can test this to see if it's a function using the vertical line test. So given a graph of f, if every vertical line that can be drawn, right, vertical meaning up and down, that can be drawn intersects the graph no more than once, then f is a function. Yay! If any vertical line intersects the graph more than once, so an x has more than one y value, the graph of f of x does not represent a function. So let's take a look at an example real quick. So here we have a linear equation, right? This is f of x equals ax plus b. It passes the vertical line test. Here we have a parabola. This is our quadratic function. Friendly little refresher. It passes the vertical line test. Here's some things that are not functions. First off, this guy over here, right? Because this vertical line, this x has 2 y values. Same thing here. This x has 3 y values. Circles are definitely not functions, right? And neither is this rotated absolute value function.